Hi everyone, I'm Brendan Lafferty, publisher of Rubber and Plastics News. Rubber and Plastics News is your organizer of ITEC, the International Tire Exhibition and Conference. Welcome to ITEC's Ask the Expert, our live stream series featuring the latest technology for the tire and rubber industry. With Ask the Expert, this is your chance to learn from professionals who are addressing the current business environment and discussing its latest developments. ITEC has a number of Ask the Expert sessions scheduled each day at noon Eastern. And the entire library of Ask the Expert sessions are available on our virtual event site, found at itechvirtual.crane.com. Today, Ask the Expert will explore automating semi-materials through to the curing area of a tire plant. Our expert today, Mr. Don Heelis, Sales Manager, Tire and AGV Systems at Cimcorp Automation. Now, Don will answer questions after his presentation. If you do have a question, you can send them at any time to rpnevents@crane.com, or if you're watching the live stream on Facebook, LinkedIn, or YouTube, send your questions through those platforms. With that, I'll turn things over to Don Heelis at Cimcorp. Don, the floor is yours.
Thank you, Brennan. In this presentation, we will consider automation from the semi-materials area through to green tire delivery to the curing presses. Solutions presented here can be considered for both brownfields and greenfields. Specifically, however, brownfields bring their own unique set of challenges, and as will be shown, unique solutions. The object here is to discuss how standard automation modules can be made adaptable, variously configured, and integrated to handle these challenges. Next slide, please. Competency is key to be capable to take on these challenges. Required are skills with a range of robot automation equipment, the ability to integrate this equipment at the cell control level, the software expertise to orchestrate these cell-level activities, and higher-level software that manages the work. And then the ability to adapt and change based on potentially varying parameters. Next slide, please. Illustrated here are standard modules that can be deployed throughout the tire factory. On the left side of the picture, you can see high bay warehouses that are used for raw materials. Could be natural rubber or various ingredients used in the compounding process. In the mixing area, you can see various types of AGV systems that are used for handling the compounded rubber and storing those materials into automated storage areas or static racking, which can be serviced by the AGVs. In the tire building area, in the center of the image, we use Ems Systems for collecting the green tires from the curing presses. In the curing area, we'll deploy AGVs or even Ems Systems to make the delivery of the green tires to the curing presses. In the testing area, various gantry applications are used for buffering finished tires before the testing machines, and after that, gantry robots for sorting, stacking, and palletizing the tires. And then finally, those palletized tires are stored in high bay warehouses. And the last aspect of the factory is the order picking and shipping, where gantry robots can fulfill those orders and automatically stream them out to trailers. These modules need access to intelligence. This is provided through the WCS, the MES, and the MCS. Next slide, please. It is not enough just to have excellence with integrating automation systems, but also an in-depth knowledge of tire manufacturing is essential. Next slide, please. At the plant floor level, consider mixing, for an example. It's a batch process, raw materials in, semi-materials out. The scheduling function creates missions for the automation, and having real-time feedback based on downstream events such as quality or production bottlenecks is critical. Next slide, please. Tracking and tracing products with electronic identifiers, which are stored to known locations, with these known locations also having electronic identifiers, is key. AGVs are given emissions from a fleet management system. The fleet management system creates priority queues for the AGV activity. The fleet management systems receive instructions via the MCS through integration links from the surrounding production cells. Next slide, please. Various ASRS configurations can be utilized, which can encapsulate the production cell. On the input side, receiving from the ASRS is input WIP, and feeding directly the outbound process materials to another ASRS. At the cell level, there are no non-value-added handling activities. Next slide, please. AGVs can service production cells directly, and with fixed racking can create a very flexible and efficient storage grid. Next slide, please. The AGV tractor module is standardized, and by attaching various appliances, a range of payloads can be handled. The payload interfaces should be standardized as much as possible to further simplify the system. Next slide, please. The use of vertical storages provide high-density utilization of the available floor space and can be ideal for landlocked brownfield facilities. Next slide, please. Tire building machines can build green tires at cycle times less than 60 seconds, and it's not acceptable to inhibit or restrict the production of these machines. In certain cases, the tires must be weighed immediately after building to validate requirements with direct real-time feedback for quality purposes. Next slide, please. EMS systems, or also known as overhead electrified monorails, can be a cost-effective and very reliable means to move green tires. The tires are handled by the bead with servo-controlled tire tools to minimize the quality impact of handling. Next slide, please. Conveyors with specialized belting can transfer and sort green tires at high speeds. Activated rollers within the belts can provide touchless diverting functionality. Next slide, please. Green tire storage and retrieval. Because green tire codes are built in batches and at rates faster than they can be cured, they must be buffered. And in the buffer, you must know exactly what you have, exactly where it is, and immediate access to it on demand. Next slide, please. Gantry systems with stackable totes are well suited to fit into brownfield manual tire supermarkets. The totes are designed to accommodate the contour of the green tires and minimize any quality impact. Next slide, please. Mini-load cranes can handle 2 tires at a time, ideal for tandem curing presses. With mini-load systems, in some cases, green tires are stored in tire totes, which are also conveyable. And the mini-load cranes can actually handle the tire totes and not interact with the tires themselves. Next slide, please. Racking is an important part of the mini-load system. The storage bunks must be designed to handle the range of tire sizes that the plant manufactures. Corner totes in the storage bunks evenly support the green tire, maintaining its design shape while it sits there in storage. Next slide, please. Mezzanine buffers serviced by gantries are economical and can reduce floor space requirements and fit over existing equipment. The next slide, please. Forward-picking gantry buffers. These gantries can be extremely beneficial as interim storage in the curing area to minimize green tire delivery times from the central ASRS system. Instead of buffering tires at the curing press, centrally located, these buffers keep the curing area clear of clutter and unobstructed for mold changing. Next slide, please. Tire painting is typically a necessity and can be complicated by inside and outside painting, as well as avoiding contaminating the barcode. The right solution saves space and complexity. Next slide, please. Tire spotting. The green tire must have a specific orientation when placed into the mold. This produces the best result for quality. Each mold has its own harmonic setting. Typically, the datum is the bead barcode, which defines the sidewall splice location. The next slide, please. Press delivery systems can be overhead or by AGVs. Various factors influence what is the right solution for a given application, such as building constraints, curing layout, and curing times. Next slide, please. EMS systems minimize equipment on the floor and deliver to press shuttles that can buffer tires right at the press. Next slide, please. The EMS can be arranged in different configurations and tailored to the necessary throughput demand. Reciprocating lines and loops can provide a range of performance characteristics. Next slide, please. Safety requirements with the appropriate interlocks are designed into this system. Tires are delivered vertically by the EMS through safety enclosures. Next slide, please. Forward picking systems can directly load AGVs, reducing the number required and minimizing lost cure time. Next slide, please. Special purpose AGV vehicles for press delivery with sophisticated software can be easily implemented and commissioned in very short periods of time. These can be very economical solutions for TBR factories as well as PCR factories with the right configuration. Now we can take questions from our audience.
All right. Well, thank you so much, Don. Great information there. As a reminder to our viewers, you can submit questions at any time, multiple ways. If you want to email, use rpnevents@crane.com. And if you're watching the live stream on social media, LinkedIn, Facebook, YouTube, send your questions through those platforms. All right, Don, here we go. In brownfield factories, can this type of equipment fit within existing building constraints? And if so, how's that done?
So that's one of the unique aspects of these automation modules. They're configured in a way that they can be connected with various configurations. And those configurations can be adapted to just about any type of brownfield factory out there. So the analogy is something like Lego blocks. So our automation modules would be Lego blocks, and depending how you connect those blocks together, you can create many different configurations. So we put these blocks together, and we put them together in a way that's unique to the particular facility that we're trying to service.
Yeah, that makes a lot of sense. So Don, here's a question from our audience on LinkedIn. Can Don comment on the dust mitigation strategy needed for sensing automation to work with minimal downtime?
So that's a good question, and certainly in the tire factories, that's perhaps one of the more aggressive environments for that. So, and I'll speak to that question specifically as it relates to AGVs, and the automated guided vehicles use laser scanners as part of the navigation process. And the lens on those scanners has to be kept clean, or the data that scanner is receiving from the factory can be distorted or slightly corrupted. So having a very well-defined maintenance program is extremely critical. So, for example, lenses on laser scanners should be cleaned on a consistent schedule and in a very consistent way, such that it doesn't affect the performance of the equipment.
Well, and I think in your presentation, you also said there's really no wasted movement here. So I imagine because of that, that also helps to keep dust levels at a minimum.
Well, that's true too. So the automation equipment certainly goes a long way to help the plant housekeeping, and that has an enormous impact in terms of the consistency in terms of how the plant operates, and the cleanliness.
Yeah. So another question here for you, Don, on the macro side. What are the overall advantages of implementing this type of automation? We talked about dust just now, mitigation. What else? What else are you thinking?
So probably the predominant advantage is making your operations more productive, more competitive, more efficient, and producing higher quality products.
Mm-hmm.
So if we look at a brownfield factory that has a nominal amount of automation, after we've implemented automation, it's not uncommon to see the utilization of that plant increase, or in other terms, the output of that plant on a daily basis to increase. So that plant has a defined amount of production equipment. By adding the material automation equipment, we can actually get more throughput through their defined production equipment. So it makes their facilities more productive, and they're able to create better value.
Yeah. So one of the things when you automate, you know, how does that affect the humans working there? So the question that's come in: how do we transition our personnel to be able to sustain or maintain in an automated environment?
Yeah, so that's a very important question, and the key to this is training, and not only training itself, but how the training is done. And so when we put automation into a brownfield factory, what we like to do is their current workforce is trained by our people on the equipment, both starting when the equipment is being installed, such that they understand the nature of the equipment, how it goes together, and they work with our people when we're commissioning the equipment, so they get a sort of an intuitive feel for how it operates. And then after it's commissioned, they go through formal classroom training on more technical aspects of the equipment. So part of the strategy is, when you're implementing automation systems into the factory, is to bring the employees into the factory along with the process. And having a proper training program is key.
Yeah. Well, I think this question dovetails nicely with that. In existing facilities, how do you implement the automation without taking that tire plant offline, or is that just inevitable for a window of time?
You know, it's not inevitable, and part of the planning process, when you start looking at a facility in terms of how you're a brownfield facility, in terms of how you're going to automate it, is giving that very critical consideration. So there's a number of ways and strategies that you can deploy to do that, and thinking it through very carefully is obviously key. So, and what you find is, when you deploy the automation, you actually free up plant floor space, and by doing that, it enables you to, that space that you free up, to then move some production equipment into it, and then free up more space for implementing more automation equipment. So you go through it in a sort of a piecewise fashion, where as you put in the modules, you're not disrupting the whole plant, but you're working in a certain area. And then once that's up and running, typically you've created some space available in the factory, and then you continue cascading through like that. But starting at the very beginning and working out that strategy is key. But it can be done. It's not always straightforward, but there are ways to do it.
Yeah, and for the neophyte like myself, I imagine even if there's a little bit of slowdown at one point, the efficiencies you gain later probably more than make up for that.
Absolutely.
Yeah. So here's a question that came in from Facebook, Don. I'm not sure that it's worded properly. It says, which kind of natural rubber are you using? Examples: NBR, SBR, SMR20, crumb rubber. Any thoughts on that?
Yeah, so that's really a question for our customer, the manufacturer,
Yeah.
and what their recipe is for their compounding rubber processes, and what we can comment on as being the automation suppliers. We're able to handle any type of natural rubber in any type of packaging format that comes into the facility with our equipment.
Yeah, you're rubber agnostic then.
That's a good way to put it.
Okay. All right. So here's a question: how long does it take for any parts of this system, any of this automation, to be put in place from initial order to delivery?
Depending on the size and scale, typically, you can be as short as 6 months.
Mm-hmm.
And if you're looking at implementing this automation through a large area of a brownfield factory, you would want to do the project in phases. So you could range out to almost 2 years, for example, depending on how you phase the project. So, and phasing the project is a key to implementing it without disrupting your current production. So,
yeah. So another question about training and personnel. You touched on this. What kind of training is provided for buyers of the AGV system from Cimcorp? How does that work?
Yeah, so there's various levels of training that we provide. So there's safety training, number one.
Yeah.
Number one priority. And then operator training. And then there's maintenance training that's provided as well. So typically there's 3 tiers of training that's provided, and the training is hands-on training or in-field operational training, and then also classroom theoretical training.
Okay, so plenty of training available.
The better our customers are trained, the more successful we are. It's a critical aspect of the implementing the automation systems.
Yeah. So here's a very from YouTube. Here's a very straightforward question. Don, can you talk a little bit about the return on investment? It's a very short, simple question, but I'm sure these things, these systems, when a company buys it and invests in it, when can they start seeing some real return?
The returns are seen immediately. So once the automation equipment is implemented, then the customers start experiencing the paybacks that they've been anticipating. And so the paybacks, typically they're reduced cost, higher quality, and more efficient operations. So, and let's say there's 2 aspects of the payback that are not so obvious. Quality improvements. They're because of the way the tires are handled, and they're always handled consistently. Our customers see an increase in the quality of the output. But if we look at the whole factory, and if it's been a large-scale automation implementation, there's an increase in throughput. So before the automation, if the factory was producing, let's say, 10 million tires a year,
Mm-hmm.
it might be after the automation has been implemented, they're producing 10,500,000 tires a year. So there's a tremendous cost savings associated with that. So that increase, if you want to say utilization or increase in efficiency of the facility, is a really significant aspect of the payback, which typically is not recognized as one of the dominant payback factors.
Right. Yeah, I think that's a great example. Very So thank you for all the questions out there from our viewers. Again, if you have any, send them to rpnevents@crane.com or send them through the YouTube, LinkedIn, or Facebook platforms that you're viewing this on. Don, question, are these automation systems and products available worldwide, or are they just specific to certain regions of the world?
We're a global supplier. We're active in the majority of the countries in the world. So key, we're a global supplier, but we're able to act locally. So in North America, the plants that we work in, we're there with local people, say local technology, and working in the local language and in the local culture, no matter where it is in the world.
Right. Yeah, I think that makes all the difference in the world. I know. Well, Don, I think that is all the time we have for questions today. Thank you to everyone who submitted questions. Don, any final words or parting thoughts for our viewers today?
No, just thank you for tuning in to the presentation and your questions. And if there's any other information you need or insights in terms of these automation systems and the value and payback and how they're deployed, then please contact me, and we will answer any questions that you have.
Wonderful. Well, Don, thanks again for sharing your thoughts. As he said, if you would like to reach out to Don directly, his email address is on the screen. Also, congratulations is in order to Cimcorp, which yesterday won our Journey to Automation Award in the tire manufacturer supplier category for improving data analytics of the tire factory and its tire production dashboard. Now, to see all the winners of our J2A, our Journey to Automation Awards, visit the event website, itechvirtual.crane.com. My thanks again to our expert, Don Heelis at Cimcorp. My thanks to you for watching iTech's Ask the Expert. I'm Brennan Lafferty. Thank you for watching iTech Ask the Expert, organized by Rubber and Plastics News. Don't go anywhere. We have a parting message from Cimcorp.